In February 2025, scientists detected an asteroid heading our way. If it hit, it would create a crater the size of Manhattan and unleash a shockwave strong enough to flatten everything within 30 miles. Uh-oh, I'm out of here. Well, luckily for now, we're in the clear. But the threat is coming back in 2028, and this time, everything might change. You see, in 2025, NASA announced that an asteroid, called 2024 YR4, had a 3.1% chance of hitting Earth in 2032. Now, in asteroid terms, that's high enough to sound the alarm. The asteroid itself is not the end of the dinosaurs level, but it's big enough to level a city. The rock is about 130 to 300 feet wide. That's roughly the size of a large jet. Now, if something that size slammed into a populated area, it wouldn't end the world, but it would result in a very, very bad day. And still, no one panicked, and scientists weren't scrambling for bunkers. Because when we first spot an asteroid, we have to work with limited information. It's like seeing a plane high up in the sky and trying to guess exactly which gate it'll park at. That's why astronomers rush to gather more data. The asteroid itself seemed pretty ordinary. It was rocky, not some rare metal thing. It was first spotted in late 2024 by an observatory in Chile during a regular skyscan routine. There's this group called the International Asteroid Warning Network. Their job is to keep an eye on space rocks that might try to ruin your day. And back on January 29, 2025, they announced that the chances of that particular asteroid hitting Earth had gone over 1%. Now, 1% might not sound like much, but that's enough to make scientists start worrying. The impact risk for 2024 YR4 reached its highest point on February 18, 2025. That's when scientists calculated a 3.1% chance it could hit Earth. But by February 23, after more observations came in, that possibility was essentially ruled out completely. The asteroid's Torino scale rating, which is used to categorize the impact risk of near-Earth objects like asteroids and comets within the next 100 years, was lowered to 0. It means it's no longer considered a threat to Earth. Well, for now. But scientists still keep tracking it, and based on additional data, there is now a 4% chance it could hit the Moon instead. If that were to happen, it would be on December 22, 2032. Right now, the asteroid is expected to pass about 5,600 miles from the Moon's surface. However, there's a very large uncertainty range, about plus or minus 46,000 miles. So it could easily miss the Moon by a very large distance. The last time we had something this dangerous was back in 2004, with an asteroid called 99942 Apophis. Back then, it had a 2.7 chance of hitting Earth in 2029. People were sweating. But after better observations, scientists ruled out the impact. This time we actually passed that old record. 2024 YR4 is currently heading out toward Jupiter's neighborhood and won't swing back close to us until 2028. And that's when everything might change. If the risk jumps above 10%, the IAWN will send out a formal warning to the United Nations. They'll tell countries in possible impact zones to maybe start preparing, because if we talk about the damage… Admittedly, this asteroid is not the 6-mile-wide monster that wiped out the dinosaurs 66 million years ago after hitting Earth. This here asteroid is in the city killer category. It sounds dramatic because it is, but it's not some global extinction stuff. The real problem isn't just its size, it's its speed. If the asteroid hits, it could be moving nearly 40,000 miles per hour. That's like flying from New York to LA in under 5 minutes. But still, the most likely scenario would be the asteroid exploding in the air before even hitting the ground. That's called an airburst. But if the asteroid is on the bigger end of the size estimates, it could actually reach the surface of our planet, slam into the ground, and make a crater. So that possibility's still on the table. As for where it could hit, the possible impact zone covers a huge area: Eastern Pacific, Northern South America, the Atlantic, Africa, the Arabian Peninsula, and South Asia. Raise your hand if we left you out. Keep in mind, though, that it's way too early to make life decisions based on that. So, no packing up and moving yet. Besides, we're not sitting here helpless. In 2022, NASA pulled off the DART mission, where they literally smashed a spacecraft into an asteroid to nudge it off course. And it worked. DART stands for Double Asteroid Redirection Test. It was built for NASA's Planetary Defense Office. They wanted to know if we could push an asteroid just enough for it to miss our planet. So they launched a spacecraft in November 2022, and it traveled through space for about 10 months. The plan from day one was to crash it. The target was a small asteroid moon called Dimorphos, which is about 530 feet across, the size of a large stadium. Dimorphos orbits a bigger asteroid called Didymos. The two of them just circle each other out there in space. What's important is that neither of them was threatening Earth, so this was a safe test. Now, DART was basically a heavy spacecraft with a camera and a smart guidance system. The strategy was to hit Dimorphos at about 14,000 miles per hour and let the force of that impact slightly change its orbit. In the final stretch, the spacecraft guided itself. It had to figure out which rock was which, lock onto the smaller one, and adjust its path without anyone steering it in real time. When it hit, the onboard camera sent back close-up images right up until the moment of impact. Then the signal stopped because the spacecraft had done its job and smashed into the asteroid. There was also a small Italian CubeSat that separated earlier and stayed back to photograph the collision and the resulting debris cloud. Those images showed a huge plume of rock and dust blasting out into space. Well, after that, astronomers around the world started measuring the orbit of Dimorphos very carefully. Before the collision, it took 11 hours and 55 minutes to circle Didymos. After the impact, it took 11 hours and 23 minutes. That's an impressive 32-minute difference. The interesting part was that the spacecraft alone wasn't responsible for all of that shift. When DART struck the surface, it threw tons of rocky material outward. All that rock and dust blasting off gave the asteroid an extra push, stronger than the spacecraft alone could have done. Scientists later realized that Dimorphos wasn't a solid chunk of rock. It was more like a loose pile of rubble held together by gravity. That probably helped produce more debris and a bigger push. So if we ever face a denser, more solid asteroid, the same technique might not have the same exact effect. That's why scientists are also looking at other ideas, like using lasers to heat up part of the asteroid so bits of rock fly off and slowly push it in the opposite direction, like giving it a tiny built-in rocket. Or they could place a spacecraft close to the asteroid and use its gravity to slowly pull it off course, like a small tugboat guiding a huge ship. Or if things got really serious, use a nuclear blast as a last resort shove. Despite the success of the DART mission, NASA says we do not have a ready, reliable system that could stop a city-killing asteroid if one suddenly shows up on a collision course with Earth. The danger isn't the giant dinosaur-level asteroids. Those are huge and easy to track. Neither is it tiny rocks that burn up in the atmosphere all the time. It's the middle-sized ones, around 500 feet wide. Scientists estimate there are about 25,000 near-Earth objects in that size range moving near Earth's orbit. So far, we've only found about 40% of them. That means most of them are still out there, and we don't know exactly where they are. The problem is they're dark. Most don't reflect much sunlight, so even powerful telescopes can miss them. To help fix that, NASA plans to launch a new space telescope called the Near-Earth Object Surveyor. Instead of looking for sunlight bouncing off asteroids, it'll look for heat. Even a dark asteroid absorbs sunlight and gives off heat, and that's easier to see in infrared.
In 2022, we deliberately destroyed a multi-million-dollar mansion by smashing a spaceship into an asteroid called Dimorphos, just to see if we could nudge it off course. And now, in late 2026, another spacecraft is arriving there to check out the huge crater we left behind, and the future of our planet kinda depends on this mission. How come? Let's figure it out. First things first, let's figure out what the DART mission was and how it did its magic. DART stands for Double Asteroid Redirection Test. It was a mission built for NASA's Planetary Defense Program. Sounds like something from Star Wars. The idea was simple but important. If an asteroid were ever heading toward Earth, could we nudge it just enough so it would miss our planet? It's like with a rolling ball. A small tap can change its path so it moves past you instead. Scientists wanted to see if the same idea could work with asteroids. So NASA launched the DART spacecraft in November 2021. It spent about 10 months traveling through space before it reached its target, which was a small asteroid called Dimorphos. It was about 530 feet across, roughly the size of a large sports stadium. It orbited a bigger asteroid named Didymos. Neither of those asteroids was dangerous to Earth. That's why scientists chose them. It meant they could run this one-of-a-kind experiment safely. No need to worry about accidentally sending a real threat our way. The DART spacecraft itself was pretty simple. It was something like a heavy box with solar panels, a camera, and a smart navigation system. The plan was to slam it into Dimorphos at an insane speed of 14,000 miles per hour. That's fast enough to travel from New York to Los Angeles in about 10 minutes. But hitting a small rock in space isn't easy, especially at such a high speed. In the final hours of the mission, the spacecraft had to guide itself because signals from Earth took too long to travel back and forth. The probe used its camera and software to figure out which asteroid was the big one and which one was small. Then it locked onto Dimorphos and adjusted its path automatically. As the spacecraft rushed closer and closer, the camera kept sending images back to Earth. Scientists watched the asteroid grow larger until suddenly the transmission stopped. That was when DART smashed into the surface. Luckily, there was also a small Italian mini-satellite traveling with DART. Earlier in the mission, it separated and stayed at a safer distance. When the impact happened, this little spacecraft photographed the immediate aftermath of the collision and the resulting debris cloud. A huge plume of dust and rock blasted into space, stretching thousands of miles away from the asteroid, like a cosmic smoke trail. After the crash, astronomers around the world started measuring Dimorphos. Before the impact, it took 11 hours and 55 minutes for the asteroid to circle Didymos once. After the collision, that time changed. Now, the orbit took 11 hours and 23 minutes. This difference of 32 minutes is actually a big shift for an asteroid orbit. It meant the experiment had worked. But there was one catch. The spacecraft wasn't the only thing that pushed the asteroid. When DART slammed into the surface, it blasted a huge amount of rock and dust into space. All that material flew away, acting like the exhaust from a rocket engine. It gave the asteroid an extra shove, and that shove was much stronger than the spacecraft alone could have caused. Besides, soon, scientists realized something else. Dimorphos probably wasn't one solid rock. It was more like a loose pile of rubble with lots of smaller rocks and dust clumped together by gravity. Imagine a floating gravel pile instead of a single giant boulder. Ah, now you get it. So, because the asteroid was kinda loose, the impact kicked up much more debris than the researchers expected, and it resulted in a stronger push. The problem is, that might mean that another asteroid will behave differently. And if we ever have to deal with a solid, dense asteroid, the same trick might not work again. That's why scientists want to find out what really happened to Dimorphos after the crash. We know the asteroid's orbit changed, but we don't understand yet how the impact changed its surface or what the inside of the asteroid looks like. That's why we had to send a follow-up mission. The European Space Agency launched the spacecraft Hera, named after the Greek deity of marriage, to take a closer look. Hera is supposed to fly to Dimorphos and study the asteroid in detail. The spacecraft will map the crater left by the collision, measure the asteroid's new orbit, and study how the surface changed when DART slammed into it. It will also try to learn what's beneath the surface of that space rock. It'll go like this. Once Hera arrives, it won't just fly past the asteroids. Instead, it will orbit the system for several months, studying it from up close. It'll measure the crater and map the surface in detail. This way, scientists will be able to figure out exactly how the impact changed the asteroid. Hera won't be working alone. About 6 weeks after arriving, the spacecraft will release 2 tiny helper satellites called Milani and Juventus. These small spacecraft are known as CubeSats, mini satellites about the size of a shoebox. One will study the chemical makeup of the asteroid's surface, helping scientists understand what the rock is made of. The other will look beneath the surface using special instruments to learn what the inside of the asteroid is like. Hera is a part of our first mission to closely study a binary asteroid system. Such systems are still a bit of a mystery to scientists, even though they make up about 15% of near-Earth asteroids. While it's there, Hera will also help researchers test several new technologies. For example, it'll use autonomous navigation. That means it can guide itself around the asteroid without constant instructions from Earth. Kind of like how self-driving cars navigate roads here on Earth. Hera will give scientists a clearer picture of how asteroids behave in a crash. That way, next time we try to push one off course, we'll know exactly what to expect. By the way, DART and Hera were designed together from the beginning as part of an international project called the Asteroid Impact Deflection Assessment. Missions like DART and Hera are helping scientists learn how to protect Earth if a dangerous asteroid is ever discovered in the future. Because, according to NASA, we still don't have a fully ready and reliable system that could stop a city-killing asteroid. The thing is, the biggest asteroids, the kind that wiped out dinosaurs, actually aren't our main worry. They're enormous and, therefore, much easier to spot and track with telescopes. Scientists would almost certainly see them coming many years in advance. Tiny space rocks aren't a problem either. Small pieces of debris enter Earth's atmosphere all the time, and most of them simply burn up in the sky before they ever reach the ground. The real threat is medium-sized asteroids, about 500 feet wide. That's around the size of a large skyscraper, or several football fields laid end-to-end. An asteroid that size could destroy an entire city if it hit Earth. Scientists believe there may be about 25,000 near-Earth objects of this size moving around the Sun on paths that pass close to Earth's orbit. But so far, we've only discovered about 40% of them. That means most of them are still out there, and we don't know exactly where they are. Many of them are extremely dark and reflect little sunlight. That's why even powerful telescopes can sometimes miss them. No wonder experts are exploring different ideas for planetary defense. One option is using powerful lasers. The laser could heat part of the asteroid's surface until bits of rock start flying off into space. Those escaping particles would act like tiny rocket exhaust, slowly pushing the asteroid in the opposite direction. Another idea is something called a gravity tractor. A spacecraft would park near the asteroid and hover there for a long time. Its gravity would pull on the asteroid, slowly tugging it off course. It's like a small tugboat guiding a massive cargo ship. And if things ever get really serious, there's still a last resort option, using a nuclear blast near the asteroid to give it a powerful shove.
So, we just spotted an asteroid so massive it could wipe out an entire continent if it ever hit Earth. And it's moving insanely fast, almost record speed. But what makes it really scary is how it's basically playing hide-and-seek with us. It can slip right into the sun's glare and vanish completely. And yeah, it just did it again. It disappeared. So, when we finally spot it again, will we have enough time to prepare? Or could it already be too late for humanity? Do I have your attention now? Thanks. So, meet 2025 SC79. That's a mouthful, so I'll just nickname it Scooby. This newly found asteroid is a sneaky one, the kind that loves hiding in the sun's glare. Think of it as trying to spot a firefly next to a stadium light. The brightness hits your eyes and outshines anything faint nearby. So yeah, you won't see that firefly. Now asteroids hide in the same frustrating way. When they end up close to the sun from our point of view on Earth, the glare overwhelms our telescopes, and the asteroid's dim, reflected light gets lost in it. That's why some asteroids can cruise along in the sun's direction and stay basically invisible to us. And scientists say the most dangerous asteroids, the ones that could wipe out a whole city, are the hardest to detect. That's why astronomers need to somehow dodge the sun's glare. One way they do it is by observing the sky during the short window of twilight. I mean, right before sunrise or just after sunset. And that timing is a big deal, because it's the only way to catch some risky asteroid before it sneaks up on Earth. Scientists say that if one of these so-called twilight asteroids ever gets close to Earth, it could be a serious impact threat. And it was during one of these twilight observing sessions that scientists finally spotted this huge asteroid. It was September 27, 2025. Scott Shepard, an astronomer at a Washington-based institute, was scanning the sky, hunting for anything unusual in our solar system. And he had an incredible tool in his hands, the Dark Energy Camera, or DECAM, one of the most powerful sky survey cameras on Earth, built to spot faint objects across huge areas of the universe. At one point, he spotted a faint dot moving across the image, so he quickly aimed the high-tech camera at it, and things got more interesting. Its movement matched what astronomers expect from asteroids that orbit very close to the Sun. Then, follow-up observations with the Gemini and Magellan telescopes confirmed the discovery. Yes, this really was an asteroid, and there are two particularly curious things about it. First, it's fast, like really fast. In fact, it is the second fastest known asteroid orbit in the solar system. It loops around the Sun once every 128 days. For comparison, Mercury, the closest planet to the Sun, takes 88 days to go around once. Second, its orbit is super rare. This is only the second known object that stays completely inside Venus's orbit. That also puts it in one of the rarest asteroid groups out there, the Asteroids. These are asteroids whose orbits sit entirely inside Earth's orbit. Astronomers have found only a few of them so far, and Scooby is the 39th one in the list. The team of scientists also figured out that this asteroid is pretty big, measuring about 2,300 feet across. That's roughly the size of Merdeka 118, the second tallest building on Earth. If an asteroid this size ever slammed into Earth, it wouldn't just be bad, it would be catastrophic. We're talking about damage on a continental scale. It would blast a huge crater into the ground, then throw out a shockwave powerful enough to wipe out forests and wreck cities. Seismic waves would ripple through the crust, triggering widespread earthquakes around magnitude 7.4, and people could still feel them about 300 miles away from the strike. And that's not all. A brutal air pressure blast would race outward, shattering windows more than 1,000 miles away. Then comes the aftermath. Dust and debris from the impact could shoot up into the atmosphere, block some sunlight, and mess with our climate. I know, you might feel scared right now, but don't worry about it. Thankfully, Scooby isn't going to do anything like that, because it's not on a collision course with Earth. Right now, the math shows it won't be making any close passes by our planet, at least not anytime soon. Still, there's a lot more to learn about this asteroid, but any further studies will have to wait. For now, it has disappeared behind the Sun and is out of sight. Once it reappears, astronomers will take a closer look and try to learn more about what it's made of. That part really matters, because this asteroid is somehow holding up while orbiting so close to the Sun's brutal heat. You see, this asteroid gets very near to the Sun. At its closest point, this asteroid is blasted with almost 6 times Earth's sunlight. At that distance, its surface could heat up to about 440 degrees Fahrenheit. What scientists don't know yet is how a rock this big can get baked over and over again without falling apart. And there are 2 more things astronomers want to check once it comes back into view: how fast it spins and how bright it looks. Now, by bright, I mean how much sunlight it reflects, because asteroids don't make their own sunlight. They're just big rocky chunks that shine by reflecting sunlight back at us. Anyway, those clues can tell scientists what Scooby is made of. One possibility is that this asteroid is loaded with dense metal, and that could explain how it survives the Sun's brutal heat. And if that turns out to be true, This asteroid could be a relic from when the solar system was just forming. Or maybe it slowly moved closer to the Sun because the gravity of Venus and Mercury gently pulled on it again and again over millions of years. Now, even though SE79 isn't a real danger to us, and there's still a lot we don't know about it, just finding it is already a big deal. It's a reminder that big asteroids can hide from us. So even in our own cosmic backyard, there are still blind spots where large objects can stay hidden until the right moment of twilight gives them away. And as our detection tech gets better, we keep finding more and more asteroids. By now, scientists have spotted over 1 million in the solar system. They come in all sizes, from monsters like Vesta that measure about 329 miles wide, all the way down to rocks that are smaller than a house. Now, out of all the asteroids we know, about 40,000 are what we call near-Earth asteroids, or NEAs. That just means their orbits bring them close to our neighborhood. Technically, their closest point to the Sun is less than 1.3 times the Earth-Sun distance. It's close enough for planetary defense systems to keep a careful eye on them. And that's exactly why we can relax. I mean, nobody has to lose sleep imagining an asteroid slamming into our planet. Every time scientists discover a new asteroid that comes anywhere near Earth, they track it and run the numbers right away. And then they map out its path years, decades, or even centuries into the future. And they don't do it by guesswork. NASA's automated systems, like Sentry, constantly scan the asteroid catalog and calculate whether any of these objects has even a small chance of hitting Earth over the next 100 years. If something looks risky, it jumps to the top of the watch list and gets followed up fast. So yeah, there are almost 2,000 near-Earth asteroids that technically have some chance of hitting us in the next 100 years. But don't panic. Most are small and harmless, hey, like me. And their odds of impact are usually way under 1%. See why I said we shouldn't stress too much? Cool. Now, sleep tight.
Did you know that over the past year, around 150 asteroids whizzed closer to Earth than the Moon? But that's not the scary part. It's that some were only noticed after they flew by. And if even one of those had taken a slightly different path, whole cities would be gone. That's what keeps the scientists worried. The invisible stuff, hiding where our telescopes can't see. Let's explore what that means. Astronomers keep a list of asteroids that wander into our neighborhood. If a rock's orbit comes close to Earth, it joins a special club we call Near-Earth Objects, or NEOs. That list can include anything from a harmless little space pebble that wouldn't break a window to a rock big enough to cause an earth-shattering kaboom. NEOs are leftover materials from when the planets were forming. Some of that rubble ended up tucked safely in the asteroid belt between Mars and Jupiter, but some pieces got nudged onto paths that cut across Earth's orbit. Those are the ones we care about, because they're still wandering around today, looping around the Sun, and every now and then passing uncomfortably close to us. The biggest objects are the easiest to locate. They are rare and bright enough that they stand out in sky surveys. So far, none of those big ones seem to be heading our way anytime soon. However, the real anxiety comes from the middle class of asteroids. On paper, many of them sit in the potentially hazardous object category, or PHOs, but the nickname City Destroyer explains them better. These rocks aren't huge enough to wipe out the planet, but they could flatten a city and mess with the climate for a few seasons. Some are as wide as a football stadium and hit the atmosphere faster than a speeding projectile. NASA estimates there are around 25,000 near-Earth asteroids at least 460 feet wide, but we've only discovered a fraction of them. Basically, we have solid orbits for less than half of the City Destroyer crowd. The rest only exist as numbers in simulations. We know they should be out there. We just haven't seen them yet. Why are they so hard to spot? Some asteroids are nearly coal black, blending into the cosmic night. Others hang out close to the sun from our perspective, so our telescopes get overwhelmed by brightness. It's like trying to locate a mosquito while staring directly at the sunlight. Please don't do this. From Earth, these rocks are mostly lost in the sun's glare. We only catch a glimpse just after sunset or right before sunrise. And that chance only exists if the sky is perfectly clear and the asteroid happens to be in exactly the right spot. If not, it slips back into the sun's blind spot, playing hide and seek with us. We were caught by surprise quite recently. In 2013, the Chelyabinsk meteor came from the direction of the rising sun. No one saw it in time because it was coming from the wrong direction. It exploded high above the region, shattering windows across the city and sent more than 1,000 people to the hospital. The scariest part is that the meteor was only about 60 feet wide. Now imagine a city destroyer coming from that same direction. A stadium-sized rock stepping out of the sun's glare would give us very little warning, maybe a few days or a week instead of decades. And we know that the blind zone is not empty. Observations have already revealed at least one large asteroid in that region that scientists can seriously consider a planet destroyer. It's called 2022 AP7, and it's huge. This thing is more than half a mile wide, big enough that if it ever hit Earth, it would be a catastrophic day for everyone. Astronomers found it by using the super-sensitive dark energy camera during twilight, pointing the telescope at the region of the sky most surveys normally avoided. The good news is that AP7 isn't headed straight for Earth. Its orbit crosses the orbit of our planet, but the timing doesn't line up, so we won't encounter it this pass, the next one, or even for several centuries. The bad news is what that discovery hints at. If it took this much effort to notice something like this, what else are we missing? And 2022 AP7 is just one PHO. Other asteroids closer to the sun were also spotted during those same twilight searches. New simulations say some of those hidden rocks are not random. A bunch of them seem to share an orbit with Venus. They do not orbit Venus itself. They orbit the sun in almost the same lane, sometimes a bit ahead of the planet, sometimes a bit behind, like kids jogging on the same track but spread out along the lap. Astronomers already know about roughly 20 of those Venus co-orbitals, and their paths are anything but stable. Gravity from Venus, Earth, and other planets keep tugging on them, and over thousands of years, those pulls could stretch their paths until they start crossing Earth's orbit. Most flybys are harmless, but one unlucky pass could be the one that counts. So what can we do about this? The first step is simple in theory. Find them earlier. The goal for astronomers is to launch infrared telescopes and get them into space. While we do have amazing telescopes like JWST or the Hubble Space Telescope, they're never pointed at the sun, as the brightness of our star can damage them. That's why we need a telescope in orbit around Venus, or one that travels along with it. It would be in a much better spot to keep an eye on the asteroids that hang out there. NASA is launching the NEO Surveyor project that aims to solve the problem. It should scan the inner solar system to spot dangerous asteroids in time. Also, we're learning that we can actually move asteroids. NASA's DART mission rammed a small spacecraft into a rock, which affected its orbit slightly. Not by much, just enough to prove that it can be done. It's like turning a plane just 1 degree while it's still across the ocean. By the time it reaches you, that tiny change can make it miss by thousands of miles. Teams around the world spend their days babysitting space rocks, and yes, that's a real paying job. NASA has the Planetary Defense Coordination Office. Europe has the NEO Coordination Center. Observatories feed them nightly sky data, and computers immediately check each dot's orbit. If a rock might wander too close, it joins the risk list and gets extra attention. Each new photo updates the orbit a little more, sometimes that make the danger level rise for a moment. That is exactly what happened with 2024 YR4, when it briefly reached level 3 on the Torino scale before better measurements calmed everyone down. The scale itself runs from 0 to 10, and anything that climbs above 3 is rare enough to raise eyebrows. The whole system works that way on purpose. Notice something strange, collect more data, then decide whether to relax or stay alert. Most of the job is actually pretty dull. It's a lot of number checking, orbit fixing, and crossing out false alarms. That quiet, careful routine is what lets the world respond quickly when a rock finally appears that isn't just passing by. So how worried should we be? For those huge planet-destroying rocks, the short answer is not much. Nothing that size is on the near-term schedule. Smaller city-level threats are trickier. The odds of one hitting Earth anytime soon are still tiny, but they're not zero. Think of it as a cosmic lottery that has been running for billions of years. Every once in a very long while, the universe draws a number that makes astronomers sit up and pay attention. It's not a reason to panic. It's a reason to build better eyes in space and make sure that if a bad ticket ever comes up, we see it in time to do something about it.